In this video, I'm going to show you how to make an enemy that patrols around the board. We're going to need something called an array, which is a block of variables or a group of variables or a list that has a fixed size. That's another way to think of an array. And we're going to need something called an index, which is a variable that says which thing in the array do we currently want. And that thing that we want is going to be the room to move the guard to. So in this example here, I'm trying to make some sort of trope where you sneak into the World War II German castle and steal the blueprints to the secret something or other. And I want to have a guard that patrols from north of castle to the inner courtyard to the stable and back. Just boom, 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 over and over and over again. Now, I don't want the guard to move every turn. I think that would seem too fast. It would be, be like turbo guard or something. I don't think that's the way to go. So I'm going to have another variable that acts as a counter, and I'm going to start it off at 0 every turn. I'll add 1 to it. When it gets to 5, then I'll move the guard. So I'll have a count up timer. I could have a countdown timer too, either way. But I'm going to start a counter at 0. 1, 2, 3, 4, 5. Move the guard. Set the counter back to 0. 1, 2, 3, 4, 5. Move the guard. Set the counter back to 0. 1, 2, 3, 4, 5. Move the guard. Set the counter back to 0. Just like hitting a snooze button. So that's how we're gonna do this. So let's pop over to Lantern and let's take a look at what we have here. So under rooms down here, rooms and objects, I've got a guard 50. He's my guard. He's the 50th object. So he starts off in the inner courtyard. Now, how are we going to model his moving around? We're going to do that using an event. So an event is code that runs every turn. And we maybe don't have to do something every turn, but every turn we're going to check to see if we need to do something. So that's what we're going to do is we're going to make an event here, and it's called move guard 50, because guard 50 is our guard. So we're going to go over all of this code and talk about what it does and see how it moves the guard. Now, before we get into this code, though, we've got to figure out how to model the path that the guard is going to follow. And we're going to do that using an array. An array, as I mentioned before, is a list of fixed size. It is a block of variables. It's a group of variables. So I have one here, an array called guard 50 path. So to make a new array, just type in the name of the array and say how many slots you want. And what's in every slot? Well, a slot can store a 1 byte value, which is enough to store a room ID. Perfect. So I made an array here with 4 slots called guard 50 path. And in the first slot, which is slot 0, I'm storing a 17. In the second slot, I'm going to put a 6. In the third slot, I'm going to put a 5. And in the fourth slot, I'm going to put another 6. And to change the value, you just double click on here and type in whatever you want. So what are 17, 6, 5, and 6? Well, those are the room numbers for those locations that I want the guard to patrol. So if we go back to our, you can see that the stable is object 17, and the inner courtyard is object 5, and north of castle is inner courtyard is object 6, and north of castle is object 5. So I think we're going to go 17, 6, 5, 6, and then back to 17. So let's go back to our array. You can see here that at some point, like we're going to run out of something. We've only got 4 values stored, and we're going to move the guard to room 17, room 6, 5, and then to room 6. And then where do we move the guard to? Well, to figure out where we're going to move the guard next, we're going to use another variable, or a variable called an index. And you can see that variable right here. I made a variable called guard 50 index. The index is storing which slot I'm going to move the guard to. So when index is 0, I'm going to go into slot 0 and get out the 17, and that's where I'm going to put the guard. Then I'll add 1 to the index, and the index will be 1. So the next time I move the guard, I'm going to go into the array using my index and grab out the 6. So I'll put the guard in room 6, which is the inner courtyard. Then I'll add 1 to my index. And my index will be 2. So the next time I move the guard, I'll go into my array and grab out the thing in slot 2, and that's going to be a 5. So I'll put the guard in room 5. And then we'll add 1 to index, so index will be 3. When we move the guard, we'll say go into the list, get out the thing in slot 3. That'll be a 6, and we'll put the guard there, so the guard will be back in the inner courtyard. And then the next time we move the guard, we'll say, okay, well, hang on. The index is bigger than 3, right? The index has gone past the range of valid values. So I've got valid indexes here are 0, 1, 2, and 3. If I add 1 to that and get now my index is 4, that is not a valid index, right? I don't have a slot 4. So I have to set the index back to 0. So we'll have to, our index will creep up. It'll go 0, 1, 2, 3, 4, and then when it hits 4, we set it back to 0, and that's going to make the guard go 6, 17, 6, 5, 6, back to 17. So the index is used to say which thing out of this array do we want to grab. And then what else have we got here? We've got a guard 50 delay variable. That's our count up timer. It's going to go 0, 1, 2, 3, 4, 5, move the guard, set that thing back to 0. This is just a counter, so we don't move the guard every turn. And then guard 50 state, I'll talk about that in a second. So let's go look at our event now for moving the guard, and this should make hopefully some sense. Right here, this is where I'm adding 1 to my count up timer. So plus means add 1 to. So add 1 to my count up timer. If my count up timer has hit 5, now I'm going to move the guard. So I'm not moving the guard every turn. I'm only moving it when the timer hits, or the counter hits 5. And then at the end, you can see I'm setting the counter back to 0. So 0, 1, 2, 3, 4, 5, move the guard, 0, 1, 2, 3, 4, 5, move the guard, 0, 1, 2, 3, 4, 5, move the guard. All right, so now let's look at this line here, and we'll look at this other stuff in a second. So this is the crux of the whole thing. This array name followed by the index in the square brackets. This means go into the list and get out the thing at that, whatever guard 50 index is. So if guard 50 index happens to be 0, we're going to grab out the thing in slot 0. If guard 50 index is 1, this is going to go into guard 50 path, grab out the thing in slot 1. If this is, if guard 50 index happens to be storing a value of 2, then we're going to go into the guard 50 path, and we're going to grab out the thing in slot 2. And every time we grab something out, we're going to store it in the guard 50 holder. We're going to move the guard 50 there, basically. So we're saying go into our list and grab the next room to go to and put the guard there. And then down here, we're going to say, okay, good, now add 1 to the index. So the next time we move the guard, we'll put the guard in the next place that was stored in our list. But remember, we've got that problem where our array has only got 4 slots, 0, 1, 2, and 3. So if the index ever hits 4, we have to set it back to 0. And if we go past the end of our array in the test client will blow up and throw an error and say, hey, you tried to access something outside of your array. If you try to do this in the assembly language exports, the results will be random and undefined and probably not what you want. So there's no bounds checking down at that level. But if you're running in the test client, then it will catch any array index out of bounds errors that you might have inadvertently, time bombed into your game. All right. So, and now let's go look at this bit of code here and this bit of code here. So all this is doing is just letting the player know that the guard moved somewhere else. So right before we move the guard, we're going to say, are the player and the guard in the same location? And that means they have the same holder, or the same parent, or the same location. Those are parent, holder, location are all synonyms. So if the player's location is the same as guard 50's location, they're both in the same room, right? So when we move the guard, from the player's perspective, it's going to look like the guard just wandered off. So before we move the guard, we'll just check to say, hey, is the guard here? And if he is, then we'll say the guard wandered off. Then we move the guard. And now what we're going to do is check to see, we're going to do the same check. Is the guard where the player is? And if after moving the guard, if the guard's in the same place where the player is, we're going to say, hey, a guard just wandered over. Because now, after moving the guard, they're now in the same place. So these are not, strictly speaking, necessary, but they will really help the player visualize what is going on by telling them where things are moving around in the environment. But and then again, we're doing all of this inside of this outer loop that is just making sure it doesn't happen every turn. We're gonna do this every 5 turns. 0, 1, 2, 3, 4, 5. Move the guard, set guard delay back to 0. So this is if the player and the guard are in the same place and we're about to move the guard, print the guard wandered off because we're about to move the guard. Then we move the guard. After we've moved the guard, are the guard and the player in the same place? Okay, good. So we just move the guard into where the player is. So we'll say, hey, a guard just wandered over. Then we'll add 1 to our index. If our index went out of bounds, set it back to 0. And then we reset our counter so we don't move again. All right, and we're going to put this all in an event that runs automatically. So events run every turn. Let's just verify that this all works. Test, launch player. Okay, so here's my World War II trope in progress. So let's get in the truck. All right, and then the guy fixes the flat tire, drives us up and around the hill into the castle, and now we're in the back of the truck, and let's just get out. The gravel road ends, blah, blah, blah. The road extends back to the east. The driver's standing here smoking a pipe. Well, let's look at the driver. The driver appears to be an older man, probably unfit for frontline service and relegated to less demanding duties, right? So he's, I don't know, I'm trying to build up a sense of empathy there. I'm trying to I don't want any violence in this game. I want it to be a stealth game. All right, so now let's go into the castle here. Oh, the guard wandered off. Okay, so the guard is standing here surveying his surroundings. So we moved into the courtyard, but then the guard moved. But because the guard was in the same place as us, the guard wandered off. Well, where'd he go? Probably went north. No, south. There he is in the stable. Okay, so a guard is standing here surveying his surroundings. So let's wait. Time passes. Wait. Oh, the guard wandered off. Okay, so look. So there's no guard here. Let's go back to the inner courtyard. Oh, look, there's the guard. The guard is standing here surveying his surroundings. Wait, wait, wait. The guard wandered off. All right, so look, there's no guard here. Let's go north. There's the guard, right? Wait, wait. Actually, if we go south, the guard wandered. Oh, the guard wandered over. So we went south, but so did the guard. Okay, and we just wait here. Wait, 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 wait. Now we have to wait for the guard to go back to the stable, sit there, and then come back, turn around. Wait, where's the guard? Wait, wait. Look, north of castle. Well, the guard seems to be here. It seems to be working. The guard is standing here. The guard wandered off. Okay, so it seems to work. All right, so there you go. So that is how we can model an object or an enemy that kind of patrols around the board using that array. We could use if statements for this. That would be awful. It'd be so many if statements. I mean, imagine that this path was like there's like 8, rooms that the thing's got to go through. That's a whole lot of if statements. We can condense that all down into one lookup, one array lookup. Just build a list of rooms we want to go to, keep track of which one of those rooms the player's that thing is currently in, and when we move it, we say, okay, just get out the next one. So that, using the array syntax with the array name followed by the index and the square brackets, that will save us a ton of code writing. Now, one final thing. Imagine that this guard could exist in multiple states, right? Maybe the guard can be patrolling, or maybe he could be dead, or maybe he could be, talking on a telephone or something, or talking to another guard, or who knows. Maybe we don't want to move the guard every time. So what I would do then is maybe define the states that the guard could be in. So maybe in my variables here, I would make some states. Like maybe I would define like a variable called dead, like in caps or something. I'd say, I'd make that, 1 or something. Now I've got a variable called dead, right, that has a value of 1. And now maybe I'll make you know, I'll make another variable like on the phone. This is totally useless to my game, but you know, and then now, so now I have another variable called on the phone, right? I've got dead and on the phone. So now I can basically make a third variable that stores which one of these states is the guard in. So if I make a variable called guard 50 state, I can assign it dead or on the phone, or maybe I assign it patrolling. Maybe I make up one called patrolling here. Make that 3, click add. And, you know, maybe guard 50 state, where's that? So, you know, maybe I should put him in the patrolling state. So maybe, can I change the value of that? Let's change that to, what's patrolling? Patrolling was 3. So let me change the guard state to 3, so he's patrolling. Variable updated. Cool. All right, so now what I'll do is let's go to the event here. I'm going to take all of this code that I put in this event. I'm going to cut it out of here. I'm going to put it in a function. Oh, and I've already got one here, guard 50 patrol. So I made a function called guard 50 patrol. I'm going to put all my code in there. So now what I've done is I've taken all that, the code that's just specific to the guard moving around, and put it in a function. And now in my event, what I can do, I can say if guard 50 state is equal to patrolling, I hope I spelled patrolling right, then what do I want to do? What was it called? Guard 50 patrol. Guard 50, then I can call guard 50 patrol. All right, and that's the syntax for calling the function is just like C, open parentheses, close parentheses, semicolon, right? There's no concept in Lantern of passing parameters. So now every turn, I'm going to check the guard state. I'm going to say, is the guard in the patrolling state? Oh, he is. Okay, then make the guard wander around the board. But maybe if the guard was in the dead state, then don't, right? So, you know, otherwise if, else if tab, there we go. Guard 50 state, can't type to save myself, equals dead, right? Well then, you know, I probably don't want to do anything. Actually, that's a bad example. But so if the guy's dead, don't do anything. But maybe, you know, maybe he's injured and then he dies or something. Ooh, I don't want to think about that. All right. So, well, but what we've done is now we're getting into something called a finite state machine, where the guard could exist in a series of different states. And in the event, we're going to check what state he is and call the correct function to make the guard do whatever is appropriate for that particular state. So there we go. So that's a little complicated, but, you know, and if you don't like that, we could just keep everything in the, you know, you can just keep everything in the, in one event. There we go. Just keep it simple. Save it. But there it is. So that's how you can model an enemy that follows a path. You just have to build an array of the rooms that you want that enemy to traverse, and then add an index that keeps track of which one of those rooms you want to go to next, and just make sure that your index never gets bigger than the number of things, bigger than or equal to the number of things in your array. All right, well, there you go.